in this part, we're going to go ahead and talk about classification of reactions, so the 6 types of reactions, and we're also going to continue reinforcing the balancing of equations in this tutorial. So the first type of reaction is synthesis, or also known as direct combination, where you take 2 substances that are combined and they form a single compound. So here's the key point: single. That means you have only one product. So for example, A is our generic plus B. So these are our generic terms. So A plus B react with each other to yield a product, one product, and we'll call it AB. Now if we look at the next couple problems, let's go ahead and look. So remember, synthesis is always 2 or more reactants that form one product. So here's nitrogen reacting with hydrogen, and it produces ammonia. Now, we have now written the chemical formulas that are part of the chemical equation, but it's not completed yet. We still need to balance this out. And just to do a quick review, let's go ahead and do my favorite way of doing balancing reactions, and that is creating a table. My table is going to have 3 columns. The first one is E to represent the elements, R for the reactants, and P for the products. So if we look, first thing we're going to do is write down the elements in the chemical equation. So in the reactant side, it says there I have a nitrogen and a hydrogen. I don't have anything else playing a role in this chemical equation, so that's it. Next I have to do is count how many elements I have on both the reactant and product side. So nitrogen here, based on its subscript, is going to have 2 in the reactant. Hydrogen is going to have 2 in the reactants. And then if we look over here, nitrogen does not have a subscript, so I'm going to write that it has 1. And hydrogen has a subscript of 3, so that means I have 3. And so what I'm going to do, I'm going to go ahead and just leave hydrogen for last, and let's go concentrate on nitrogen. Our key thing here is we want to make sure the numbers in our reactant are going to be the same in the numbers of our products. So if I have 2 nitrogens in the reactant side, I have to have 2 nitrogens in the product side. So in order for us to have that, I have to multiply this by a factor. And I'm going to have to multiply this by 2. So if I have to multiply this by 2, I'm going to be putting a coefficient in front of ammonia of 2. This changes my number of nitrogens to 2. So now I have 2 nitrogens. But this also changes the number of hydrogens I have. 3 times 2, because now I have a multiple of 2. I have to change this 3 now to 3 times 2, which is 6. Now my hydrogens don't match. I have to now multiply this by a factor in order to get it to 6, and that factor has to be 3. So I'm going to put a 3 in front of hydrogen, and that changes this to 6. Now my numbers match from the reactants. I have 2 nitrogens in both the reactant and product side, and I have 6 hydrogens in the reactant and product side. Now that we have this balanced, it is a completed chemical equation. Just like the previous slide, this is still synthesis, so you have 2 reactants to produce one product. Now phosphorus is P4, and oxygen is O2, and reacting those 2 yields tetraphosphorus, so P4 decaoxide, O10. Now go ahead and pause it here and try balancing this reaction on your own, and when you're done, unpause it and see if your answer matches mine. You should end up with 1 phosphorus, 5 oxygens, and 1 tetraphosphorus decaoxide. Now, decomposition, instead of forming a single compound, you actually start with a single compound. So let's say we start with AB, and you break down into one or to more than one product. So you'll have A plus B. Sometimes you can have a plus C and plus D, but in general, you're going to start with one and end up with having more than one product. So again, you have one reactant, and it breaks down to have two or more products. So you have hydrogen peroxide, breaks down to water and oxygen. And again, go ahead and pause it here and balance the reaction. And you should end up with 2 hydrogen peroxide, 2 water, and 1 oxygen. Again, here is decomposition. You start with ammonium nitrate, and you decompose to one or more. In this case, you have 3 products: nitrogen, oxygen, and water. And again, go ahead and do the table. Balance this, because this is not a complete equation without balancing it. Pause the video, try it on your own, and then unpause and you should get the following answer. Two ammonium nitrate, 2 nitrogen, 1 oxygen, and 4 water. And the final one that you're going to have for decomposition, you have nitrogen triiodide and breaks down to nitrogen and iodine. If we do the final balancing of this equation, go ahead and pause it and press play again. You should end up with the following balance equation: 2 nitrogen triiodide, 1 nitrogen, and 3 iodine. The third type of reaction is single replacement. In a single replacement, you're basically replacing a free element, and you basically swap. And if I have, here's A. A is my free element, and I have another compound, BX. What will happen is that my X, which could be a halogen or any compound, is transferred to the A, and so my product will have AX, and I will have B, now a free element. So again, here's the equation, the generic equation. A plus BX yields AX plus B. So if you have potassium and water, so I can go ahead and think of water as HOH. And if I do a single replacement, what's happening is that the hydroxide is moving to the potassium, and the hydrogen is left on its own. So you end up with KOH, potassium hydroxide, and hydrogen. But again, this isn't balanced, so we still have to balance this. And your final balanced equation should be 2 potassium, 2 water, yields 2 potassium hydroxide and 1 hydrogen. Here's aluminum and lead nitrate. So you have aluminum and lead nitrate. Again, we're going to take this nitrate, and that's going to swap places. So you have aluminum now. It's aluminum nitrate plus lead. Okay, so if we go ahead and do that, let's go write out the chemical equation. You end up with aluminum plus lead 2 nitrate yields aluminum nitrate plus lead. Now, this isn't done. We still have to write a balanced equation, and you should end up with 2 aluminum, 3 lead 2 nitrates, and yields 2 aluminum nitrate and 3 lead. Again, here's fluorine. Now, instead of us changing the halogens, or what we've been doing, we're like halogens or the polyatomic ion. Now we have halogens, fluorine and bromide, and we are going to now swap the metal. So fluorine ends up being cobalt 3 fluoride plus bromine. And if we write that down, we should end up with this equation. You end up with F2 for fluorine plus COBr3 for cobalt 3 bromide yields COF3, which is cobalt 3 fluoride, plus bromine, and it has to have a 2 because bromine is a diatomic molecule. And if you notice, what we swapped was the metal. The metal went from bromine to fluorine. And let's go ahead and balance this. So if you end up balancing this, your final answer should be 3, 2, 2, 3. Now that we've done single replacement, our fourth one we're going to talk about is double replacement. Now, double replacement, you're going to have AX plus BY. And instead of replacing just one element, you're going to go ahead and swap two elements. So the X and the Y will swap places, and you end up with AY plus BX. So again, here is a generic formula. So here is silver nitrate, AgNO3, and calcium chloride. And we're going to go ahead and swap to form silver chloride. So the nitrate and the chlorine are going to swap places, and you end up with AgCl plus calcium nitrate, CaNO3, 2. Now we still have to balance it, and if you balance it, you should have this 2 silver nitrate plus 1 calcium chloride plus 2 silver chloride, 2, plus 1 calcium nitrate. Now in this example, we have lead nitrate reacting with potassium chromate. And if we do a double replacement, we're going to take the nitrate and the chromate and swap places. So you end up with lead 2 chromate and potassium nitrate. Now again, you can go ahead and pause it and balance the reaction. So if you do so, you should end up with one lead nitrate, and 1 potassium chromate, and that should yield 1 lead chromate and 2 potassium nitrate. And in this last example, we have magnesium chloride and sodium phosphate. And to have a double replacement, let's go ahead and look at the chlorine and the phosphate. They'll swap places, and you should have magnesium phosphate. So magnesium phosphate and sodium chloride. Now let's go ahead and balance this out. And if you balance this out, you should end up with 3 magnesium chlorides, 2 sodium phosphate, 1 magnesium phosphate, and 6 sodium chloride. Now, our fifth type is a neutralization. And with a neutralization, you always have an acid reacting with a base. So let's go ahead and write acid, which is typically H and either this could be right there. X is going to represent a halogen or a polyatomic ion. and it reacts with a base. So, and a base in this case is always some type of hydroxide. So I'll go ahead and write this as a metal hydroxide. So it's MOH. And neutralization is basically just another way of doing a double replacement. Because what happens is this hydrogen and the metal, they will swap places and you end up with the metal with X plus HOH. In other words, HOH is also water, H2O. So in neutralization, you always make a salt and water, always. So let's go ahead and look at a couple of neutralization reactions. So in this example, you have hydrochloric acid reacting with calcium hydroxide. And all we're going to do is look at the hydrogen and the calcium, and they should swap places. So you should end up with hydrogen having H2O plus calcium chloride. Now, we need to go ahead and balance this reaction. You should end up with 2 hydrochloric acid reacting with 1 calcium hydroxide, and you form 2 waters and 1 calcium chloride. In this example, we have sulfuric acid reacting with potassium hydroxide. And again, we're going to go ahead and do a double replacement. Swap these two out. You should end up with water and potassium sulfate, K2SO4. Now, we need to go ahead and make sure that we balance this out. You should end up with 1 sulfuric acid, and you should have 2 potassium hydroxide, and you should yield 2 waters and 1 potassium sulfate. And for our 6th and final reaction, we're going to have combustion. Combustion is where you have a hydrocarbon, meaning that you have a carbon and a hydrogen bonded together, and they could have different amounts of carbon and hydrogen, and they are always burned in the presence of oxygen, so air, O2, and it always produces carbon dioxide and water, always. So combustion is when you have a hydrocarbon reacting with oxygen and always produces carbon dioxide and water. This is a key thing, always produces carbon dioxide and water. So for here, again, let's go ahead and write down the essential equation. You have propane, also known, which means it has 3 carbons and 8 hydrogens. That's what propane is. And it's always going to react with oxygen to form carbon dioxide and water vapor. So let's go ahead and balance the reaction. You should end up with 1 propane, 5 oxygen, 3 carbon dioxide, and 4 water. For butane, butane has 4 carbons and 10 hydrogens. Again, it always reacts with oxygen, and it forms carbon dioxide and water. So let me go ahead and write the chemical formula. Now that I have this, let's go ahead and finish it off by balancing the reaction. You should end up with 2 butanes, 13 oxygens, 8 carbon dioxides, and 10 water. So for the next 4 problems, I'd like you to go ahead and First, balance the chemical equation, and then identify the type of reaction. Go ahead and try this problem, this problem, this problem, and this problem on your own.